Hi, I'm George Hammond, conference producer for Technology Networks, and I'm here to introduce our next talk from our Technology Spotlight sponsor, LabVantage. Ultimate Impact, an invitation to define the lab of the future. I'm pleased to welcome our next speaker, Mark Moorman. Mark works in business development for both LabVantage and TCS Digital. In these roles, Mark leads the go-to market for the analytics solutions for both companies. He works closely with customers, partners, and associates to drive successful outcomes by leveraging data assets for business value. Mark is a data scientist by trade and training, which enables him to act as a trusted advisor to customers and to understand how business problems can be successfully solved with the use of technology, data, and algorithms. Mark holds degrees in computer science and business analytics. A warm welcome to you, Mark. Following on from the presentation, we will have a Q&A session, and we welcome any questions that you may have. Please ask questions using the Q&A system to the right-hand side of the video player. You can also use this feature to connect with attendees and discuss the talk, so feel free to take advantage of the chat system by introducing yourself and sharing your thoughts during this presentation. You can also benefit from some fantastic supporting literature from LabVantage, which you can download for free below this live stream player. If you experience any technical difficulties during the presentation, please request help using the technical help icon in the menu on the left-hand side of the player. Without further ado, I will now hand over to Mark to begin your presentation.
Thank you, George. I appreciate that. Thank you very much. So I feel a little awkward trying to see the future. That's always difficult. But I do believe there are several things that we know that are coming in the near future. And as laboratories today, we need to be prepared to meet those challenges and make those changes. A couple of them, I think, if you look across the top, these are trends that are already on. We already know these things. Some of us are already doing them. Sort of becoming more smart about quality, or trying to integrate quality into an AI tool, or use something that is more automated for quality, or trying to automate as much of quality as possible. Driven by shortage of technicians and other things, and global demand. So there are these challenges that exist today that we know about, but there's some emerging trends that are also shaping the way labs are working. Obviously, the COVID-19 showed us that there are times when we have to respond in a much faster mode than we have in the past, and be resilient and do a great job in a short time. And that brought on some new changes. It sort of shifted our modalities. It created a way for us to work as an organization that tries to minimize the things that cost us time but don't add value, while maximizing the things that add value. And I think what happened during this time is we became more, or we should have become more defined by our digital assets. And that's really what I want to talk about today, is how we mature the analytics and the AI side of the laboratory. Because I think the people in the lab work great. They've always worked great. The technicians, the scientists all work great. So one of the places that we're going to make a impact in our processes is through the use of our digital assets. And I think the winners and losers will be determined over the next few years by who can make the best use of those digital assets. And so I'm going to start with a real busy slide as we talk about what the lab of the future will look like. And if you look to the left of this slide, the lab today, or pretty much today. And as you move across, you'll see things that are becoming stepping stones to the lab of the future. Some of those things are you're already doing today, like LIMS systems and LES systems, and trying to integrate that data with your ERP and other information systems, and trying to basically get all of the data systemized. And most of us have been doing that for a while now, and we've got it down pretty good. Getting things into the LIMS system, getting things integrated with costing and ERPs. ELNs are becoming more and more useful, and you're starting to see that. You're starting to see some wearables in the lab, maybe not as much, but more and more you're seeing some wearables and some activities like that. And then you're getting obviously connected instruments, and that connectivity brings more and more data, and that data starts to become an asset that can change the way you do things. So if you look at that line moving down the middle, or down slightly to the right of this slide, you'll see a demarcation where we go from a lab that's just gotten more and more technical assets to a lab that has a highly integrated, highly functional technical backbone. And that's really what I think, technology backbone. And I think that's what's going to make the lab of the future, is a lab that can be digitally native. Can you use all of your assets to run what we call a digital twin? Could you look at your laboratory today on a computer screen and see all of the activity in real time as it happens? I think that's the state where we'll start to be able to bring the robotics in and bring the automation and start to look at how things will drive the lab of the future. Some of this comes with disruptions that have happened for a long time. The connectivity and processing power to run large-scale models and to collect data from all kinds of instruments and to bring that data together into a single store. And then using that data, through innovations that we have today, modeling techniques that allow us to do things like natural language processing on PDFs, to look at the PDFs that are associated with a test or a function or a consumable in the lab. And so you're starting to see these disruptive innovations drive. Robotics is coming on board. Those disruptive innovations like robotics and the models that run them and the data assets that you've collected through all of your connectivity start to become the building blocks to actually new business models, doing things a different way, maybe predicting protein folding or molecules, maybe predicting ingredients into a chemical makeup. These kinds of things become new business models, and you can actually change the way you do business, and then that accelerates change. And we've seen this in business everywhere, not just in the lab. The way that businesses like Uber and Airbnb and Tesla have changed the way that the business was done. And this is going to happen in the lab. And so getting ready for that is kind of what we have to do. Now, what I like to look at are 3 basic areas in the lab that really need to become integrated and have a functional backplane that makes them a single asset almost, or makes them almost look like a single asset. The first one I call integration. You may call it other things, but that's basically just where you're getting data. You're collecting data through your LIMS system. You're collecting data in your historian and your instruments, through your notebooks and your notes and textual inputs, through your scientific data systems. You're collecting a lot of data, and that data today, in often case, you have a data lake probably, but that data lake doesn't have all of the data in it. And it doesn't keep all of those assets integrated. And that's the integration piece, is how can you bring all of that data together and integrate it into a single asset? Now, that asset may not be a single database. Don't get me wrong. I'm not advocating necessarily that you have a single database, but I'm advocating that you have a single asset that you can use that's integrated data across your lab data, your LIMS, your financial data, your instruments, and all of that. And then once you have those assets, well, what do you do with them? Obviously, you start with some visualizations and BI. Can you just get a visual of what's going on in the lab? Where's your cost going? What's impacting turnaround time? What kind of activities is causing loss of assays or something, or a sample? And so you start to visualize things. And once you can visualize things, you can run analytics on them. And you can start to do things, just simple analytics, basically your normal calibration curve, immunogenicity, all kinds of statistical algorithms that you could run integrated into the platform. Today, they're being run out in some secondary system or somewhere else, but now you would integrate them into a single layer. And then that gives you the opportunity to add machine learning algorithms to it that would produce AI in many cases. And you could start to do things like predict molecule folding. You could start to do things like predict quality failures. You could start to do things like automate testing and not create new tests for everything that comes along. And you could start to become more AI and machine learning driven. Once you do that, then you can bring on automation, and automation allows you to use robotics to optimize processes today, obviously to start auto processing. And so the automation layer then is a way that you execute on what your digitalization layer did with the data that it integrated. And so in my mind, this is the focus of particularly the technology arms of laboratories today is, how do we get the data assets integrated? How do we get them digitalized? How do we start making use of that through visualizations, through analytics and machine learning? And then how do we put that back into the lab through automation forms, put it back into, again, robotics or functions? And that, I believe, is the basis of what the lab of the future will be built on. There'll be other things, but I'm focused on this particular area. Let's take a minute and break that down in a little more detailed way. So for instance, in this case, of course, I've got the LabVantage LIMS up to the left because I work for LabVantage, but it could be any LIMS, right? You've got your LIMS data, all of your laboratory data. Then you have a bunch of instruments that are probably being used. Then you have a lot of other laboratory data. We've talked about electronic notebooks and things like that, SDMSs and financials. And really what you want to do is build a fabric. And I want to use that term a little bit more loosely if you're a technologist and you know what a data fabric is. I'm going to use it a little looser than that. I'm not specifically talking about the technology fabric, but talking about this idea of building an access and an integration layer for all of that data that comes through a single point, not necessarily a single storage area, but at least can be derived through some single point of contact. And we call that the big data management capabilities, the ability to handle large data, or data not necessarily large, but at least has a wide variety of data in it, and get that integrated. On top of that, you'll want to have a visualization tool, obviously a BI tool. Many people use things like Tableau or Power BI or something like that. But we've seen that having an integrated BI layer into the laboratory management system allows you to do that without a lot of other quality, especially if you're a regulated industry. You can have the BI attached directly to the LIMS, will cut down on a lot of the cost of going through the regulatory requirements. And so we see a lot of people wanting to not necessarily use a third-party system, but use something that's integrated into the LIMS. And I think that's a place in the future, is that in the laboratory, the BI and the visualization will be integrated tightly into the LIMS, which will be the hub of all of this data. It'll be the place where the data starts with. And so integrating that BI, I think, is a step that you'll want to take as you grow into the lab of the future, and not start sending the data out to some third-party tool or something and having copies of data, moving data around, and having these things that happen outside of the controlled environment. And that's true with analytics and AI as well. Same thing, you'll want your analytics integrated in, and so that you can run context-centric analytics and you can run context-centric BI. And so this functionality is something that I believe is critical to the lab today, and obviously in the future. The better you can do at this, the better you'll do. So what are some of those things that you would expect to have? And many of you probably know those, but you'll want bi-directional integration into those scientific assets. You'll want to be able to bring data in from the LIMS and write it back out. You don't just want this one-way flow in the future. It'll be circular. And we know this. You kind of know this already. It'll become a system, an ecosystem. And so you'll want an analytics platform that's not only reading data, but can write it back in and has this conversational or circular relationship with your scientific assets. And it'd be nice to have some pre-built visualizations that are ready to go that define your KPIs that your business uses and makes them available. You'll have to have some self-service BI, and you can kind of read this slide at your own, but the basic point of this slide is you'll want a wide breadth of functionalities, AI and BI functionalities, but you'll want them integrated into the ecosystem of the lab, into the digital ecosystem of the lab, meaning the LIMS and the ELNs and the other scientific data, scientific applications that you use. And so I'm going to run through this really quickly based on time, but this is an important part. And if you want further conversation, we can have that at your leisure. But basically, this system means you have to take data in. That's to the left. You can see data coming in from the LIMS and the ELN and all these systems. You can see them there. You're all kinds of systems. And then you take data out, sometimes going back into those systems, sometimes going to other systems to build a process through which you can run. Inside that process, you have to have the ability to manage the data, which means, transforming the data, providing profiling and master data management, quality controls, and really have a data management layer. You'll want some way to store that data, and data has to be stored today both with structured and unstructured mechanisms. We know this. So you'll need a data storage functionality that handles, obviously, the structured and unstructured. You'll want connectors and extensions to it that you can, again, this is not a one-way or a single point, some visual slide or something, a Tableau report. This should be something that you can have access to through mobile apps, through web front ends, through other applications that would use this data to do something else and make, again, an analytic ecosystem. One of the things that we believe, at least at LabVantage and TCG Digital, is that it should be open source technologies. You don't want to get locked into a vendor-centric tool. And so we use all open source on our side. And I believe this is important as we look at the future. We're really going to want to leverage open source technology so that you can keep up with it. And then, of course, you'll want the statistical and computational to do machine learning, optimization, classification, all of those kinds of AI tools that you'll need to do to build. And that's the technology platform that you'll want. Then you'll want to also have a program management process to follow. And that's what you see on the screen now is the program management process that you should follow, or you could follow. In this case, for us, we look at use cases. So we look at how what business processes could be changed by these digital assets. And so if you wanted to do something like a self-healing master data management, or you wanted to do an auto test, or you wanted to do a straight through quality project, you would build that as a use case. And that use case would then be used to define what the data elements are for it. So you would then look at all of the data elements. Where is it coming from? What kind of transformations are required? How are those data elements brought into a co-joined relationship, and how can they be used and leveraged to meet this use case? And from there, you'll start to look at the techniques and tools. So you'll just determine what kind of platform technologies you would need, how you would drive the modeling for if machine learning or those kinds of things, what kind of integration you would need into other assets in the company to be more of an integrated platform. From there, you can start to look at how the workflow is. How will this process be put into your data processes or your daily processes, into your current processes? How will you integrate this platform into this use case into your current operational systems? And that may require open org, changes to the organization or culture or processes, meaning retraining or even shifting people around or doing some of that. So the fact is, you have these technologies, and a lot of times we get focused in on the technology. We're going to buy a technology to solve our problem. But in many AI and analytic applications, they fail, and they fail because they don't have a successful AI transformation protocol in place. And so I think focusing on the technologies is good, but it can't be your singular focus. You have to have a equal focus on the process that you're going to do to bring this into the platform. And so I think now I'll take some questions, but feel free if you have any, if you want to reach out to me or anything. I've put my email on here, and I'm certainly would love to hear from any of you. But at this point, George, I think I'll turn it back to you for questions.
Thank you very much, Mark. I'm sure everyone here will agree that that was a fantastic and insightful talk. I can see that we've received some questions already, so I'll move straight onto the Q&A now. Your first question is, we don't have any AI or machine learning experience, but we would like to start leveraging it. What recommendations do you have for people just getting started with machine learning?
Yeah, that's interesting. And I probably should have covered this. I was a little bit of a hurry there, sorry, and I didn't focus on all of the aspects. But it's true that most laboratories, whether you're a pharmaceutical, packaged goods, a petrochemical, whatever your business is, most of the time it means your business isn't AI and digital asset and digitalization. So I recommend, and this is, I think a good recommendation based on my experiences is that you should find a partner. And you should find a good partner. And that partner should be one who understands, obviously, how to run digital transformations. That's a critical part of it. But I also believe you need a partner who understands the scientific nature of the laboratory and your business in general. If you're a pharma, then you have the GXP, all of the regulatory things, Part 21 and GXP and all of those. And I think that, or 21 Part 11. And so you have all of these regulations. I think it's important that you find a partner that understands the digital aspects of it, but also understands the scientific and business sides of it. So my bottom line is find a partner who understands you, and find a partner who knows what they're doing when it comes to digitalizing or analyzing digital data.
Thank you so much, Mark. And everyone joining us online. Unfortunately, that's all that we actually have time for today. Any questions that we didn't have time to get to will be sent to the speaker after the event. Whilst you're here, don't forget to check out all of the free to download literature and resources from LabVantage available below the live stream player. And as with all the other talks in the event, this talk will now be available to view whenever you want for the next 30 days. It just leaves me to say thanks again, Mark, and we'll be back soon with the next talk.